Hello everyone. In this lesson, we will talk about derivative of tangent, cotangent, secant, and cosecant. In previous lesson, we have worked with derivative of sine and cosine. We also explored the concept of product rule involving these two functions as well. And don't forget that when we work with this type of transcendental function, we need to apply the chain rule. Derivative of sine, derivative of cos, they have their own function as a result. So derivative of sine become a cos. We still have to multiply by derivative of what the argument that you have as a function of sine. Also, you have to multiply by derivative of u as a function of x. If you are working with the function as the argument for cos or sine. So in this lesson, we will talk about derivative of tangent, cotangent, secant, and cosecant. So derivative of tangent of a function will become secant square of that exactly function again, because you have to multiply by this entire result by derivative of the argument of tangent. So similar approach for cotangent, secant, and cosecant. So let's work with the example. Okay, so as I mentioned up here for everyone, it's the same concept as we discussed in previous lesson when it comes to power rule, product rule, or quotient rule. So in this question number 7, you see that tangent is raised to the exponent 4. With the argument as 1 minus x to the exponent 5. So what you do is you identify u in this function here, which is 1 minus x to the exponent 5. Then you know that you are going to apply the chain rule. That means you have to multiply by derivative of the argument. At the same time, you have to apply the derivative of tangent. And don't forget that because it's raised to the power of 4, so your very first step that you have to take care of this function raised to a power. So let's get started with that. So I will immediately write dy over dx because I'm going to differentiate this right away. Okay, so I apply the power rule because I have tangent raised to exponent 4. So if I take 4 multiplied by the 1 in front of the tangent here, it will become 4. Immediately after, I take 1 away from the exponent, so it will become 3. 4 minus 1 is 3. Then you write the exact argument again. Okay, so we write the exact argument again. So I would like to identify for everyone, this one is your power rule. Okay, you apply the power rule when the exponent for your trigonometric function is other than 1. So in this case, it's 4. So the next step is you have to apply the derivative of tangent itself. The derivative of tangent. So what I'm going to write below here for everyone to note is derivative of tangent. Excuse me. So let me zoom it back. Okay, so derivative of tangent. Then it will become secant square. Okay, so I better write derivative of tangent. So there's 3 steps in this case. Alright, okay. So derivative of tangent, according to our formulas that you've seen earlier in this formula sheet, derivative of tangent is secant square of the function. So you write the exact function again. Okay, so I will write secant square of the exact argument again, 1 minus x to the exponent 5. And here's I close the bracket. Okay, so the next step is derivative of the argument. So in this case, I have to multiply by derivative of the argument. So derivative of the argument in this case is negative 5x to the exponent 4. Because you take 5, you multiply by negative 1, becomes negative 5. Take 1 away from the exponent, become x to the exponent 4. And derivative of 1 is a 0. Okay, so when you see this type of trigonometric function where the exponent stay right by the trigonometric function, you have to apply the power rule to this trig function. So there's always 3 steps in this case. Alright? Okay, so let me write this as simplified form. So then I should have it as negative 20 x to the exponent 4 times tangent to the exponent 3 of argument 1 minus x to the exponent 5, and multiply that with secant square of the same argument 1 minus x to the exponent 5. So basically what I have is I take 4, I times negative 5, I got negative 20, and I write it together with x to the exponent 4. So this is a very nice and neat way of presenting your final answer with the coefficient with the function raised to the exponent, and then after that you list all the trigonometric function to its power. Okay, so I would like to make a note here for everyone. So this is done. Okay, so a big note here for everyone. So if I write y equal to tangent of 1 minus x to the exponent 5, okay, I can put all of this in the bracket like this, okay, and I raise to exponent 4, then it's the same as I'm writing y equal to tangent to the exponent 4 of 1 minus x to the exponent 5. So don't forget that this is the same as this. Okay, so make sure that you realize the notation. And I also want to note this is very important, that y equal to tangent to the exponent 4 of the argument 1 minus x to the exponent 5 is totally different from tangent of 1 minus x to the exponent 5 raised to the exponent 4. So they are totally different from each other, because in this case is you take tangent of this argument and then you raise the entire thing to the exponent 4. But in this case, what you have, if you have to take the argument raised to exponent 4, then you take the tangent of that. So please distinguish the difference between these two, and make sure that if you have a case where tangent raised to this exponent, and how do you take derivative of that? Okay, take derivative of that, it means it just become derivative of tangent, which is the secant square of the exact argument, and then multiply by the derivative of this argument itself. In this case, it's just raised to exponent 4. So if you want me to quickly take derivative of this function for you, so I would write like what is derivative of y equal to tangent of 1 minus x to the 5 to the exponent 4. Okay, then what you do is, in this case, there is no power rule for your trigonometric function, but only the power rules apply to your argument. So make sure that you see the difference between these two. So then, what is derivative of tangent? Derivative of tangent of secant square. Okay, so secant square of u. In this case, I will rewrite the exact argument again to the exponent 4. Now I multiplied it by derivative of u, which is 1 minus x to the exponent 5, all of it to exponent 4. So in this case, it will be 4 times 1 minus x to the exponent 5. This will turn to exponent 3, okay, because you take 1 away from the exponent. Then, now you multiply by derivative of what inside the bracket. So in this case, you should have negative 5x to the exponent 4. Okay, so in the end, the final answer for this would be, okay, so I will have negative 20 x to the exponent 4 times 1 minus x to the exponent 5, all of it raised to the exponent 3, and then my secant square of 1 minus x to the exponent 5, all of that raised to exponent 4. So now compare the difference between these two. So let me zoom and make a comparison for everyone. So in this case, what you have is you have the answer like this, right? Okay. And in this case, you have the answer as such. So for this particular function right here, so you see this one, you don't have the tangent to the exponent 3 times 1 minus x to the exponent 5, right? So because you don't need to apply the power rule for your trigonometric function, but in this case you apply the power rule for your argument. So please note the difference between these two. Alright, so let's continue on with the next example. So the next example, what I have is 8. Number 8 is y equal to 4 over 5 cotangent to exponent 6 of the cube root of 2x. Okay, so first of all, so let's review what is the derivative of cotangent. So you go back to your formula sheet here. Derivative of the cotangent is negative cosecant square of the same argument. And then you have to take derivative of the argument. Alright, okay. So, however, in this case, you see that there's a exponent 6 beside this cotangent. So that means you raise this trigonometric function to the exponent 6. So you still have to do 3 steps as we done for example number 7. So then I will write dy over dx equal to 4 over 5 times 6. At the same time, I take 1 away from that exponent. So it will become a cotangent to exponent 5. And right after, you rewrite the exact argument again. Okay, cube root of 2x. So I will make note for everyone here. This is my power rule. Okay. Yeah. Okay. The next step is to find the derivative of cotangent, which is negative cosecant. In that case, you will eliminate this 4 over 5. You don't repeat that 4 over 5. You also don't repeat the exponent 6 in this case. So the next step is derivative of cotangent, which is negative cosecant square of the argument. So we write the exact argument again. So don't forget this is the multiplication and is the derivative of cotangent. Alright, so the last step, as you all know, is you need to multiply by derivative of the argument. Okay, derivative of the argument, cube root of 2x. So I will write it here for everyone. And then what I will do is I will do a detailed step in a minute. So it will be 2 over 3, okay, times 2x all of it to the exponent 2 over 3. So this one is derivative of the argument. Okay, so you see that you do the power rule first, then you take derivative of the trigonometric function itself, then at the end it's multiplied by derivative of the argument. So let me make a note here. How do I get to this 2/3 times 2x all of it in a bracket, raised exponent 2/3 in this case. So I will do that in a minute, but let me write the final answer. So it will be negative 16 cotangent to the exponent 5 of cube root of 2x times cosecant square of cube root of 2x, the whole thing divided by 5 times 2x, all of it raised to the exponent of 2 over 3. Okay, so as you see, how do I get 5? It's because I actually cancel the 3 with the 6 in this case, so I will have 2 left. Okay, so then I will have 4 times 2 times 2 times negative 1, so I have negative 16. And at the denominator, I just have the 5 left. Okay, so here's a note for everyone. So I have u So I let u equal to q root of 2x. Okay, then I write it like this. All of it to the exponent 1/3, and you can just leave 2 inside the bracket, and then you can differentiate. So du over dx. So I've applied the power rule. So 1 over 3 times 2x. Now take 1 away from 1/3. I should have negative 2/3. At the same time, I have to multiply by derivative of what inside the bracket. In this case, derivative of 2x is 2, so I write 2. Then to simplify this, I should have it as, okay, 2 over 3, and I bring this entire 2x down to the denominator, raise this to the positive exponent. So that's how I get my derivative of the argument for you up here. Alright, okay. So it looks complicated. However, I think if we just understand how it's supposed to work, then the algebra here is, you already know the algebra already. So take the exponent of your trigonometric function, multiply by the coefficient, at the same time take 1 away from the exponent. That means the basic power rule still apply. Okay, make sure you write the exact argument again. So don't forget 3 steps. Power rule, and just take care of the power first. Leave the exact argument the way it is. The second step is to leave out the coefficient, leave out the exponent, but only take derivative of cotangent of this argument. So derivative of cotangent of this argument with negative cosecant square of the exact argument again. Okay, and the very last step is to take derivative of the argument, and they all multiply with each other. Alright, so I will do a few more, and hopefully this few more will clarify all the rules that we're supposed to follow. Okay, so it's 17 minutes, so I have about 13 minutes left. Let's see if I can, what I can do. If not, I will have to continue with the next video. Okay, so let me pause a bit and then drink a bit of my tea, and then I will continue. Alright, okay, so I hope everyone already knows what to do in this case. You see, you have 5 at the exponent for secant. So in this case, you know that you have to apply the power rule. So apply the power rule, then apply the derivative of just secant of this same argument, and then at the end, take derivative of this argument. Okay, so let's see what is derivative of secant. So derivative of secant will be secant of the argument multiplied by tangent of the same argument, but still multiplied by derivative of the argument itself. Okay, so so let's get started with this. So the first thing is the power rule. Okay, so I write dy over dx equal to the power rule, so 5 secant to the exponent 4. Okay, take 1 away from the exponent, so secant exponent 4. Now the exact argument again, because we do 1 step at a time. Alright, so 1 step at a time. So this is my power rule. And the next step is I will have to multiply by derivative of the secant. So in this case, you are not going to worry about the exponent 5 anymore. Okay, so derivative of secant is secant again with the same argument, and multiply by the tangent with the same argument. Okay, so in this case, I will make a note. This is derivative of secant. Okay, so this is the power rule. Alright, so the next step is to multiply by derivative of the argument. And for the derivative of the argument, you see that you have this argument raised to this power. So you have to apply the chain rule in this case, again, for the argument, right? So I will write it as 2 times 3x squared minus 5x to the exponent 1. Okay, take the exponent multiplied by the coefficient in front of this, which is 1. At the same time, take 1 away from the exponent. Now I still have to multiply by derivative of what inside this bracket, which is 6x minus 5. Okay, so 6x minus 5. Okay, so how do we write this as our final answer? So basically what you do is you write this at the front, okay, and you multiply the coefficient together. So I should have 6x minus 5. So in this case, what I will do is I will, because this one raised to exponent 1, I will factor out the x. Okay, so I'll factor out the x. So I just want to make a note here. Okay, so note, it can be written as 2 times x, so multiplied by 3x minus 5, okay, times 6x minus 5. So I factor out the x. So in the end, my final answer is, so I just put it separately here. So in the end, my answer will be dy over dx will be equal to 10x multiplied by 3x minus 5 multiplied by 6x minus 5 times secant to the exponent 5, because I would like you to note that this is your secant to the exponent 4. Okay, so this to the exponent 4, and don't forget you will be combining this two term, exponent 4, and with the 1 that will be exponent 5, okay, of 3x squared minus 5x, all of it raised to exponent 2, and then I can write tangent of 3x squared minus 5x raised to the exponent 2 as the last term. So make sure that you make a combination of secant to exponent 4 of the argument. It's the same argument here, so you can combine these two, secant to the 4, secant to the 1. So 4 plus 1 will give it to the exponent 5. You can only do this when you have the exact argument, which is true, right? So you have the same arguments. You can go ahead and combine the exponent, and at the end, that is the final answer. So I have 10x because I factor out the x here, and I take 2 times 5, which is 10, and x multiplied by these two binomials and multiplied by my trigonometric function. Alright, okay, so let me rewrite the x. Okay, so I think we should continue to the next question, because this one looks good already. Every basic rules still apply. I better make a note here. I forget, derivative of the argument. Okay. Alright, so this whole thing here is my derivative of the argument. Okay, so move on to this number 10. So we are going to work with derivative of cosecant. So before we do this, let's take a look at our derivative of cosecant. What do we get as a result? Okay, derivative of cosecant could be negative cosecant of the same argument multiplied by cotangent of the same argument and multiplied by derivative of the argument. Alright, so now cosecant raised to exponent 5, it means that you have to apply the power rule. Okay, so apply the power rule. In this case, what we have is we will have dy over dx equal to, so make sure the notation is important, okay? So when you write dy over dx below this, it means that you are telling me that you are differentiating. So you apply the operation of differentiating to this. So I take 3.6 times 5, which will give me 18, okay? And then at the same time, I reduce the exponent by 1, and I write the exact argument again, okay? So this is my power rule. And the next one is, what is derivative of the cosecant itself? So forget about 3.6 here, forget about the 5 here, just take a look at what is derivative of cosecant. So I would write cosecant, and then the exact argument again, alright? Okay, so will be negative cosecant of square root of 7x multiplied by cotangent of square root of 7x. Okay, so we should this argument inside the bracket, and the next step is the derivative of square root of 7x. So in this case, it will be 7 over 2 times 7x raised to exponent a half. Okay, so I will make a note here to how I get to this derivative of the argument. So again, make a note, this is power rule, okay? This is derivative of cosecant, and this is derivative of the argument. Okay, the argument. Alright. So how do I write them as a simplified term? So what I'm going to do is make a note of this. Okay, so 2 cancel with 18, I should get 9 there. And then 9 times 7 could be 63 times negative. In front of cosecant, I should have negative 63. And please combine these two. Okay, so I'm going to make a note here. So this 2 here and this 1 here, you should combine them. So that will make it the cosecant to the exponent 5 of the argument. Okay, and then multiply by cotangent of square root of 7x. The whole thing divided by 7x, all of it raised to exponent a half. Okay, so this is good. But let me make a note, how do I get u and du over dx for u? So u equal to square root of 7x, so I can write it 7x, all of it raised to exponent a half. So du over dx will be equal to a half times 7x. Takes 1 away from the exponent, will give me negative half. At the same time, multiply by derivative what inside the bracket. Derivative of 7x will be equal to 7. And in writing this as simplified term with positive exponent, I should write it as 7 over 2 and 7x. I bring it down to the denominator here, and I change the exponent to positive a half. So that's how I get 7 over 2 times 7x, all of it to exponent a half for u up here. Alright, okay. So I still have a couple more questions to work with this lesson. I think I will leave it for the next video. Alright, thank you everyone.